Okay, this video is about the exponent law on multiplying like bases. Here we have the like base of x for both of these, and we're multiplying the two of them together. So let's take a look at the expanded view on this one. If we expand this out, we get x squared is x times x cubed is x times x. And if we're multiplying those two together, we have a total of 1, 2, 3, 4, 5 x's being multiplied, which means this is going to be equal to x to the 5th power. Now it's odd how 2 plus 3 happens to give us 5. Well, here we have 2 x's, here we have 3 x's. When we multiply them together, it does kind of make sense that we're going to end up adding those two exponents to get the resulting exponent. And from here, we get the rule or law that says x to the a, any base to the a, times, forget the times, so that x to the b would be equal to x to the a plus b. Not a very good b there. Let's redo that. B. X to the a plus b. All right, let's try some examples. In our first example here, we have like bases of z's being multiplied. So this is going to become z to the 4 plus 5, adding those two exponents, which is going to give us z to the 9th power. Now down here we have some coefficients that you may think are going to mess us up a little bit. But we have to remember that this is the same as saying 2 times x squared, and this is the same as saying 4 times x to the 5th. And we can, because the multiplication is all commutative, we can change the order to bring the 2 and the 4 next to each other, and the x squared and the x to the 5th next to each other, which is going to give us 2 times 4 times x squared times x to the 5th. 2 times 4 is 8. X squared times x to the 5th is going to give you x to the 2 plus 5, which will end up giving you 8x to the 7th power, which will be your final answer there. Okay, here's a you do. Try these 3 problems. Pause the video, try them, and then restart the video again. Welcome back. To answer these, the first one we have 2 times 5 times x to the 5th times x to the 12th. 2 times 5 is 10, so you end up getting 10. 5 plus 12 gives you 17. You end up with 10x to the 17th. Here we're going to add the exponents. You get a to the 2 plus 10, which is going to give you a to the 12th. Here you've got the 5, which is going to stay in front, times the a to the 2 plus 7. You could think about the 1 here and do 5 times 1, but that's still going to give you just 5. So you end up getting 5a to the 9th power, which is the final answer on that one. Okay, what about negatives? Well, if you have negatives on the coefficients, that's still handled the same way. You're just going to be multiplying the negative 3 and the negative 4 together first. This is all multiplying. So you can use the commutative order to make this negative 3 times negative 4 times x to the 2 plus 9, adding those exponents. You end up getting positive 12x to the 11th as the final answer on that one. Now here we have negative exponents. Well, you're still going to add them, but when you add two negatives, remember when you add two negatives, the result will be negative. The only time where two negatives give you a negative is when you're adding two negatives. Negative 2 plus negative 5 is going to give you x to the negative 7, and that would be the final answer on that one. Here we have x to the negative 7 plus 15. When you have opposite signs being added, opposite, a positive and a negative being added, you take the larger number in terms of absolute value, subtract the smaller number, the answer will have the sign of the larger number. So this becomes the same as saying x to the 15 minus 7, which is going to give you x to the 8th, and it is a positive because the original exponent, the original largest exponent, was positive. The original largest exponent was positive. So the result will be positive exponent. Okay, here's what you do. Stop the video, try these three problems, and come back. All right, welcome back. This first one here, we're going to make this x to the negative 3 plus negative 7. Negative plus a negative will result in a negative. We end up with a negative 10, x to the negative 10. Here we have x to the negative 9 plus 3. Adding opposites, it's the larger minus the smaller sign of the larger. So we are going to end up with a negative. 9 minus 3 is 6. So we end up with x to the negative 6. And we're going to have a similar situation with the next one here. We have x to the 5 plus negative 8. Larger minus the smaller, sign of the larger. We are going to end up with a negative exponent here. We end up with x is, end up with x to the negative 3 is our final answer there. And there are our three answers. Remember, the rule states that when you have a base to a power, and you multiply that by a like base to a power, that's the same as having that base to the sum of those powers. So when you have like bases, you add, like bases being multiplied, you add the exponents to get your final answer. I hope this was helpful.